GPS tracking of pets, mainly dogs and cats. And additionally to just GPS tracking, we broaden the scope now and also support health tracking as well. So heart rate, for example, or other health metrics. And you can get live position updates of your pet. You can get notified about changes in activity or sleep or other health-related changes to your pet. And furthermore, you can create virtual fences on the map. You will get notified if your pet leaves that area, or you can set up power save zones for additional battery life, or you can be warned about dangers that are close by. So if you go for a walk with your pet and you see someone laid out poison baits or similar, you can see that on the map as well. So a quick overview over this talk. First, I'll walk you through how we originally solved the whole map situation. Then how I first started looking into Compose Map back in 2024, last year, around summertime. Then how we rethought architecture as a whole for us whilst adapting to Compose, and the whole QA and rollout process after the rework, some key learnings, and then if there's time left, Q&A. So first, brief look at the map. It looks a bit cluttered here, but I just wanted to showcase some core features. So we can draw a live trace, as you can see on the right with the pin that's currently live tracking. Then we try a variety of shapes, like polylines, like as mentioned before, those virtual fences or similar, you can define. And we also can zoom to specific boundaries, like for example, if you as a user and your pet in zoom, or just the pet and so on. And we support, of course, different map types, OSM, satellite, and the standard map. And there are many, many features. You can see here a mountain lion right next to the office, so those dangers can be reported and are shown on the map. Then the map in itself, essentially right now it has two different sizes defined by our UX team, and it additionally casts a shadow, which used to be a trouble, because if you convert it to bitmap, you lose the shadow because of the way elevation is defined in the operating system. Then we optionally show a badge. You can see it right here, the blue circular view there. And optionally, we can show a text above the marker. And the tricky part was animating the marker itself or moving it along a trace, basically, like how that will be solved. So let's dive into the pre-rework architecture and brief history about it. We originally used MVP with use cases in some cases. So we had our repository, presenter, renderer, and the view. And the renderer was in between the presenter and the view, and it would just resolve, like it would be context aware, resolve resources like strings and so on, push that to the view to show it at the end of the day. And the problem was we had one repository and one presenter for one screen. So there was no real logic sharing, which was a pain, because there are many things we nearly had on every screen. I mean, we tried to build some base classes there, but it was, yeah, it could have been done way better. And the base implementation of it all was, of the whole app, was from 2016 or 2015, something like that. So we used that architecture for the whole time, basically. And the map itself, like as you saw before in the screenshots, it's used on multiple screens. So reusability is also important for a solution there. And in 2021, I first started extending the whole logic behind it, because we got new requirements. First of all, the UI of the marker itself changed. Like before, we used the standard default marker, basically, but now it became similar to what was shown before, so a more complex UI, basically. And the trickiest part was we wanted an animation, or product wanted an animation on the marker itself, which was very tricky, because at the end of the day, if you may know, the Google Map itself, it always renders out a bitmap. So the marker itself will be converted to a bitmap in a way, and that's why the map is so performant if you move the camera and so on. So I came up with 4 possible solutions. First, build the animation every 16 milliseconds, basically grab the current frame, put it on a bitmap, put that bitmap into the Google Map marker. It supports it that you push a bitmap into it, and then showcase that. But that was super hard. Like I think if you invest enough time, you will get it to work smoothly. But then my second solution was enhancing the existing marker, the existing Google Map marker, by adding views on top or behind, like trying this approach. But the problem was whenever you moved the map itself, those views you add additionally on top, they would lag behind. You could never, like the performance was just too bad. Similarly, with the third approach, just ditching Google Map markers completely, putting a view container on top, and you can basically calculate the latitude, longitude to the current screen position on the Google Map. So you could draw your own views on that view container, basically, ditching Google Map markers completely. This works, but it's also super laggy, and especially if you have many things shown on the map, like for example the dangers. If I have, let's say, 10 dangers and some markers, it could get laggy very easily. So the solution I ended up with was tying both things together, basically using the bitmap representation wherever possible, whilst no animation was running or no complex UI update was coming. And whenever I needed to animate or update the view in a more complex way, I would say, I would switch to the view version, update the view version, like to draw the bitmap basically, export the bitmap, push it into a Google Map marker, show it on the map, and that worked quite well. But it had its drawbacks. So here, a bit more explanation. Like I just said before, we had this map marker class that would hold both a view version and a bitmap version. And the view version was done in the so-called marker container, which was, as I explained before, just a layer on top of the regular Google Map. And we would switch out depending on UI changes or animations happening. And that, like I said, worked quite well. So the resulting architecture for us was we had some low-level logic classes, some use cases that used those, but the use cases would directly interact with the renderer and update the view, which circumventing the presenter was kind of an anti-pattern even back then for our architecture. And then the view would then update the marker layer. And the marker layer basically was just 3 main classes. The marker draw delegate, I called it, which was responsible for animating the marker along a trace. And the marker manager, which managed all the markers that were shown on the map and their current states, basically, and switched, like it was the brain behind it all, basically. It took care of switching between view and bitmap mode. And the map marker, as explained before, just a wrapper around the Google Map marker, extending it by our needs, basically. So an example back then would be, okay, I have 3 trackers in my app, and I change the active tracker. So I tap on the tracker I want to have in focus. I would tap on it, then the map presenter, which uses the use case, would then, like the use case would push the update, goes through the renderer, through the UI, and then through the marker draw delegate, and then finally to the marker manager. So it was a super long flow, and it was very complex to extend. Especially you can imagine if I extended by one functionality, I'd have to touch all these classes. And it just, yeah, what once started as this cute idea grew into this behemoth. So there were many issues, like I mentioned before, lack of shared logic between screens. Then obviously the overall complexity, like I touched on, with lack of extendability. Testability was non-existent, basically. And yeah, the flow was just complex for simple updates. And we had some really tricky bugs on production that were super rare, but sometimes we had duplicate pins, so both the bitmap variant and the view variant would exist. And then I had situations where many updates were coming in super fast, so I started implementing this class called marker representation queue or representation queue, which would buffer updates and then combine them in a certain interval every 100 milliseconds, calculate the new update, push that, and so on. So it became, what started as the simple idea became super complex. So that's why I started with compose map exploration, because I knew if this system changes, we're gonna move to Compose anyway, so might as well do that. So first, if you look at Compose map, it's basically just a wrapper around the regular Google map you already use. You can still access the Google map internally, like you can have a map effect, it's called, and then you can modify the existing Google map easily. And with the Google map, you get this content lambda. You can see here the advanced marker, which is inside this content lambda, and this allows you to basically use Compose on Google Map. But the flip side is this content lambda is not like a regular composable content lambda you usually face. It's a special one. It's called, I think it's annotated with Google Map composable. So it does not recompose like a regular composable, but rather uses keys, which I get into now exactly. Because for solving the marker, there fortunately was added like on August 17th, 2023, the marker composable. And with that, you were finally able to really build a marker with Compose, basically, fully customizable. Before that, that was a pain. So this way, I was able to build the marker as shown in the design system. And the way it recomposes is by providing those keys. Like you can provide an array of keys, you can freely define them however you like, and whenever one of those keys changes, it's similar with launch defect or whatever, those keys, it would recompose, like re-trigger an update. And furthermore, the marker state just holds the latitude, longitude position. It will automatically update on position change anyways. But if you need some custom update, let's say I want to show a badge on that marker, I would define a key, maybe if, I don't know, let's say an enum with the badge type. If the badge type changes, marker gets updated, recomposed, and we're good. So the tricky part was, of course, getting the shape, the pin shape correct, because as you see before here, it's teardrop shaped, and the shadow. But fortunately, you can just use the shape API in Compose. So I created this simple class, pin shape, and you need to override one function. I think it's called create outline. The shape itself is generated with AI, but that worked quite well because it's some cubic Bezier curve, whatever. Similarly, the shadow, I just used the modifier shadow. It worked quite well because you can provide it the shape as well, which is super nice now with Compose, and then you can just draw a shadow as well. Then the trickiest part was animating the marker. Again, like we used this animation you can see in the GIF, and it's a Lottie animation. And I struggled with that for a while, but ultimately I came up with the now working solution by basically running the animation. And every 2.5%, I would grab the current frame from the Lottie animation, the bitmap descriptor, and I would draw this on a separate marker behind the marker that holds the content. So the Lottie frame marker you can see in the slide, that's actually the background marker on the same position, just as a lower set index. And on top of it, I draw the regular marker. The reason I do it this way is because I tried it by extending the regular marker, like combine both of it basically, but it would be worse in performance. And in general, since in our case, like this animation shows whenever you live track, you have to trigger this manually, click a button in the app, it says start live tracking. And if you have several trackers, you could obviously trigger it for several trackers. So let's say you live track 3 trackers, you're obviously, or it's better UX, in my opinion at least, if you have the animation in sync. So this frame is also shared between all currently animating markers. And there are 2 different sizes. Like I said, the pin has 2 sizes. If it's active, it's bigger. So I calculate 2 bitmaps of the current animated frame, one smaller, one bigger, and share that between all markers, which makes it quite good performance-wise. Of course, with more markers, you still lose on performance because it still needs more redraws. But here, just took a bit of code, like the implementation. So basically, if you're live tracking, I draw this map pin animation on the same latitude, longitude as the pin itself, and then just draw the pin, that's it. Yeah, then we also show heat map on the map and other polylines and traces and everything basically. But fortunately, I mean, before that, like with the old Google Map, you also had polyline and circle and so on. Similarly, with Compose, you have those available, so all of that is super simple to solve. Like you just write polyline, you can define stroke width, whatever, color, everything. The only a bit trickier part was the heat map, because we have some custom definitions on scaling and so on. But that's also quite easy. You just add a tile overlay on the map, like you did before with the old Google Map. And like I mentioned before, with the map effect, you can access the internal Google Map, and there you just add the tile overlay, and that's pretty much how you can solve the heat map. Then animating the live trace, that was trickier, or I would say even trickier for me at least, compared to the animation on the market itself. But what I ended up with was just like if you start live tracking, you get a position update every 5 seconds. And if I animate along the trace, so I know my new position, of course, my last old position, and then I would just run the animation, in my example, for 300 milliseconds, and I calculate steps in between those two positions, and basically calculate the fractional next position towards my target position. So if I have, let's say, 10 steps in total, every 30 milliseconds, I update with a new position and move the pin to there. And it's moving along that trace, basically, like faking fractional positions in between those two positions. That's how it's done right now, and it works quite well. And yeah, here again, the code just simply, if my for loop could probably change that, but the most important part, yeah, with the callback, I call my interpolate function to calculate the next position, and the callback then gets back to the regular Google Map composable content where I update the actual pin position. That's how I solve this. So overall, the benefits I see with Compose Map, in our case, I would see it more as an enhancement to the standard map, and especially if you, which I guess most people are moving more towards Compose in general, it's very nice to use since you can build the custom UI however you like it. Like I said before, you could do that as well, but you would need to draw to bitmap and draw the bitmap on the Google marker, which was a bit tedious. Now you can really build your own composable, and that's it. And it's much easier still to animate, or at least I found it easier to handle all the logic for that. And yeah, with keys, you can really define on your own when something should be redrawn. And it ties in well with modern architecture, I would say. So then, now the UI part is solved, we got into the architecture, and in general, we changed our approach completely. We moved to control, it's called. It's a library, but it's super small. I think for this concept, you don't really even would need a library. But basically, what it does, it works like a state machine. So it's similar to Redux React. You have an action. This leads to a mutation. The state is mutated, basically. New state gets up, or the new state update will be observed by the UI, and that's how it works. So first, you put in your action, then on a mutator, it will execute all the logic, like fetch something from the database or so on, and the resulting mutation will be applied to the state and update it. So I'll give you a bit more background here. I took this from the README, the example. It's a very basic counter, but I think it's enough for a presentation. You can freely define your actions or mutation updates. Like there's no restriction from the library, which makes it quite nice. So you have just increment action, which leads to an increase value, mutation, decrement as well, and loading state. And then obviously the UI state, the resulting UI state, you have to define this again, just a regular data class, which holds the current value here and the loading state. And we usually have, for simpler screens, we have one controller inside a view model. That's enough for basically 90% of cases, but for more complex screens, we try to like split up the screen in simple, like in blocks, like sub-features, I would say, and those have their own controller, which is the case for map, which you will see in a bit. So the controller itself, like I said, it's just created inside the view model, and it's tied to a coroutine scope, to the view model scope in our case, and you have to provide it an initial state, and yeah, every time the action is triggered, the mutator callback will be executed, but you don't need to emit a mutation. Like, you can just have, I don't know, consume the action without emitting a new mutation, or you can emit multiple mutations, whatever fits you best. And then the reducer is called, the reducer callback, which receives the mutation, the update to the state, and the previous state you had, and you just apply that update, and the UI updates. That's pretty much it. So for the mutator in the counter example here, I added the increment and decrement with the fake loading state. You can see it just emits a flow of counter mutation, and yeah, just emits the loading true, then loading false, then increase, and it's, I guess, very simple, the core concept behind it. And then on reducer side, like I said, we just received the mutation. We usually just do a when on the mutations, and if it's increase value, we add 1. If it's decrease, we subtract 1, and else we set the loading state in the third case. So that's a very simple concept, I would say. I mean, it sounds a bit more difficult with the all mutator reducer, whatever, but the core concept behind it is rather simple. But one thing that might be interesting as well is handling initial loading, because usually if I open a screen, I don't want to first press some button or so before data is loaded. So the way that can be done with this library is using the mutations transformer, and here you get all the mutations, and you can just merge those, the mutations flow with your own. So basically, if I do initial loading, for example, for the map type, like knowing what map type to show, I can observe the current map type, combine it with my mutations flow, and then, yeah, update the current map type before an action was actually triggered. Now, how this applies for the map rework. So basically, at the core, I have the map view model, which has different controllers. I have one pin common controller, which is shared across different features. They reuse the same controller basically to draw map markers. And I have the overlay controller, which takes care of all the drawing on the map itself. What I mean by that is like the danger reports or the geofences we talked before, all the polylines, everything that's handled by it. And I have other logic classes that don't deserve its own controller, like the map type, as I mentioned before, because it's just too small, like it wouldn't be worth to define a whole controller for that. So that's how we do it now. So the view model is very lean. It really just receives via HILT the use cases the controllers need. I have the different controllers defined in there. They receive the injected use cases, and that's about it. And on the UI side, it's super simple as well. I just have my map composable where I just observe the states and then just, yeah, update all components as needed. Now, the benefits, drawbacks, I personally see like it's very modular and reusable, I would say. You can, like I did for the map pin, common control, define a common shared controller, share it across different features, which is pretty nice. I mean, you can share further down, of course, use cases as well and so on. Then we have great testability on every layer. Since I'm tied to specific inputs and outputs, I can, or mutations and actions, I can test it very well. Like I know, okay, I can verify if I perform this action before, for example, the increment, does this really increment my state? And yeah, I think the architecture ties in well with Compose Map. But the drawback I see is you're tied to the view model scope. So if you have the requirement of doing, let's say, you load some data or so, move the app to background, you're going to on pause, you want to stop that and go back on resume. With the view model scope, I believe it would still continue running because it only dies with uncleared. But that can be, or in those cases where we really need to be aware of this, I think with Bluetooth we had some case we handle it differently. Like you could still, yeah, there are ways to solve it. I won't go into detail now, but yeah. And controllers can grow super big. Like I said, we have these when statements for actions, and then at latest for the mutations to update the state, which could grow big, but you can always split up controllers if it makes sense, or yeah, split up in different files otherwise. Then the QA and rollout process, after I updated it all, since it was a core feature of the app, it was a bit, we were more careful with the rollout process. So I initially talked to QA, and one of the guys, he had a document with 80 plus requirements for the map screen and changes there. So I went through all of them, because initially I told him, hey, just let me know what I need to check. And I thought, okay, it's going to be 10, 15 things. But when he came with the list, I was regretting that a little. But I manually checked it all before QA, then pushed it to QA. Here we did internally, like in the Android team, we had a bug bash day, basically, where we would play around with the map. Similarly, the QA team did that as well. And yeah, for us, since we are tracking pets, we have trackers, of course, and people need to go for walks or so to test things in a realistic environment. But the whole testing process, after my first or final check with the whole list, until it was really merged, took like close to 3 weeks. So it was definitely a while. And then for the rollout, we added a feature flag. So before starting the implementation, I already added that. And we could really switch from the old implementation to the new one, like old architecture, new architecture. It was really nice because we had just one flag, and you could turn it off anytime you want, which came in handy because we had some hot fixes after the first release, and we could always switch off the feature for those versions which were faulty. And yeah, this rollout went super slow. Like I think we had stuck on 5% for 2 weeks or so, just to get more data and inform customer support there. Like I said, new issues came up, so they are the first ones, of course, that get notice of them, aside from crashes. So yeah, we had many, many hot fixes, unfortunately. But key learnings I had were, like, if you rework a complex feature, if you think it's going to take a month, it's going to take 2 months probably. At least that was my case. Like I originally started last year in October with the compose map exploration phase, trying to solve all the UI parts. And then really the final release was in March, I believe, when it was finally fully rolled out. So it took really a long time. I mean, worked on other things in between, but mostly on the map part. Then I would say before, if you make such a big change, think about the architecture first, discuss it with your colleagues. I think that's very important. Document everything, like your approach, get feedback from your colleagues, because they probably have other ideas, better ideas potentially that you don't see yourself. And what I find really, really important, solve all the known pain points. Like it doesn't help, oh, there's this fancy new technology, we want to upgrade to that. But the problem is, if you don't know how to solve everything that you had struggled with before, that's not the right way to go then. Like you really should know, have a plan, how to move forward first, and then once it's all set and done, start coding. And yeah, of course, feature flag, I can only recommend it. It was really a blessing, because then you can always turn it off if the version has any crashes or so. And of course, yeah, take your time to test, and yeah, you won't catch all bugs, unfortunately, before release, but you can always hotfix. That's the good part. And with that, that's it. So if there are any questions, I don't know how much time we have left, but you can ask.